Globally, urban populations are increasing dramatically. Coupled with overall increasing population growth and climate change, there is a need for sustainable construction of large urban buildings that conserve energy and have a sustainable relationship with the ecosystems we depend on. A recent statistic found that buildings, not counting residential, account for 36% of the total energy use in the United States. For our project, we decided to research different ways in which biomimicry could offer innovative technology for the construction of sustainable buildings. Biomimicry, which is a process of examining systems in nature and using them as technology for humans, has had a tremendous success in a variety of different fields. We sat down with Professor Adele Ashcard to see what she had to say about sustainability in biomimicry.
Definitely, we're at a stage where we have to learn from nature, and not just learn about nature, but learn from nature. And that's really a very important difference in education. It's one thing to learn biology or natural sciences or ecology and understand it, but learning from it means really understanding the little processes that happen, sometimes at the microbial level.
Biomimicry borrows mechanisms found in nature, some of which allow for greater energy efficiency, waste reduction, and more efficient heating and cooling. Michael Pollan, an expert in this field, recently emphasized the value of biomimicry in building designs in his book, Biomimicry in Architecture. In the book, he states, quote, "Many current approaches to environmentally sustainable architecture are based on mitigation. The intention is therefore to transcend the mimicking of natural forms and attempt to understand the principles that lie behind those forms and systems." We found 3 excellent examples of buildings that utilize biomimicry. Each of these buildings offer unique benefits in a diverse array of climates. The first building we examined was a cactus-inspired design for the new Ministry of Municipal Affairs and Agriculture building in Qatar. This building is based on the way in which cactuses retain water and energy, making it well suited for dry areas such as deserts. The building consists of many sunshades on its windows that gauge the temperature outside of the building. When it is hot, the shades will close, allowing the inside to cool down. When it cools down outside, the shades will reopen. By using the ever-adjusting window shades, enough energy from the sun is being extracted to be able to power the building. The kinetic energy from the shades closing and opening generates renewable power. At the same time, the regulation of the building temperature allows for normal, everyday functions to occur indoors without the need for air conditioning. These sensitive, ultra-precise shades allow the building to primarily use outside climate to maintain comfortable indoor levels. The highly effective shades capture and retain heat at night and repel the heat during the day. This simple yet effective design could also work in other places such as Mongolia, the southwestern United States, or sub-Saharan Africa. The Eastgate Center is a massive building located in Harare, Zimbabwe, and is used as both an office building and as a commercial shopping center. It typically costs an enormous amount of money to provide air conditioning for a similar-sized building. However, the Eastgate Center was carefully designed to mimic the structures of termite mounds to provide an effective cooling system using only 10% of the energy needed for a similar-sized building. The design is referred to as passive cooling, and utilizes the temperature drop between night and day to cool the building at night and then allow it to slowly rise over the course of the day. Termite mounds feature holes on both the top and sides that provide ventilation when a breeze blows on the mound. The termites themselves close and open different holes, allowing for the hot air inside to be pulled out of the structure through the network of ventilation holes. The Eastgate Center is cooled at night through a variety of fans that pull the hot air through numerous chimneys across the building until the temperature drops low enough. The Fake Hills Building project in Beihai, China was created by a company Mad Architects, an innovative architecture firm focusing on sustainable buildings. This residential building mirrors the shape of rolling hills, which naturally filter air because of their angles. The architect used undulated roofs and cuts that provide optimal views for residents. The shape of the building, along with the holes in the middle of the hills, allow natural cleansing of the air, excellent ventilation, and even filtering of sunlight throughout the building due to the equally distributed solar exposure. These two effects reduce energy consumption, which results in lower utility bills for the building's residents.
Well, I think we have a new generation of young people like yourselves who are bright, imaginative, creative, and innovative. And you guys are going to come up with products that we never dreamed of. And that's because you will not grow up with the certainty that there's going to be fuel for everybody, oil for everybody, food for everybody, clean air for everybody. So you're starting young, and we are encouraging you to really do wonderful things. And biomimicry is really one of the greatest places to look for solutions that will feed these innovations.
Although some of the general public and conventional economists perceive sustainability and fiscal prosperity to be in conflict, a focus on sustainability actually creates a smarter business plan for everyone. By internalizing the often ignored variables like environmental degradation and loss of natural resources, we can invest in technological innovation that helps us flourish without sacrificing our future.